So in this tutorial we are going to study about the greedy algorithms. So first of all I would like to describe what exactly an algorithm is. So basically an algorithm is just steps that you follow to reach a solution to a particular problem, and we can use the greedy algorithms has a very they have a lot of applications, like a lot of problems are there that can be solved using the greedy algorithms. For example, we're going to discuss the knapsack problem and the shortest path algorithm by the Dijkstra's. So the Dijkstra's shortest path algorithm, and for the Dijkstra's shortest path algorithm, the requirement is that you should know what exactly a graph is and the traversals in graph. So we will discuss these two problems, which are indeed can be solved using the greedy algorithms, but we will discuss them in separate tutorials. So let me just first define what exactly a greedy algorithm is. So a greedy algorithm is just a strategy. So I'm going to write the definition here. So the definition is, so greedy algorithm is a strategy and an intuitive algorithm that is used in optimization problems. So let's suppose you're given a problem and you want to solve it programmatically. So you will have to write the whole program to solve that problem, and basically you want to optimize that problem. And by the meaning optimization, what you have to do is you will have to decrease the time complexity of that problem. So the greedy algorithm is the algorithm that makes the optimal choice at each step as it attempts to find the overall way to solve the entire problem. So let's suppose we have a given problem which I am representing using this circle. So let's suppose this is a problem, and what you are going to do is you are going to break this whole problem into sub problems. So you're going to break it into some sub problems. So these are the sub problems. So now what you have done, you have already divided this whole problem into some sub problems. You can also call these as the substructures. So in case of a greedy algorithm, what if a programmer chooses a greedy algorithm to solve this problem, what he's going to do is he's going to solve these sub problems in such a way that he will make an optimal choice. So the basic idea is to optimize these sub problems, and when these sub problems are optimized, then they will contribute to the optimization into the whole problem. So we will see how the knapsack problem is solved using the greedy algorithm. We will divide our problem into sub problems or the substructures. So I'm going to write here substructures, and then we're going to make the optimal choice at each sub problem, and which will contribute to optimize our whole problem. So a greedy algorithm is just a strategy. It's not a specific algorithm, but it is a strategy to optimize the sub problems such that the overall problem is also optimized. So I'm going to write here a limitation of the greedy algorithm. So I'm going to write here a limitation of greedy algorithm. So let's take an example of a graph here. So I will draw a graph here. So as you can see, this is not a graph, this is a binary tree. We are taking an example of a binary tree. As you can see, I have assigned some values on the nodes here. So let's suppose we are given a problem. So I'm going to write the problem here. The problem says that you will have to find the path with the largest sum So the problem says that you will, in this binary tree, you will have to find a path that has the largest sum. So what we are going to do is we are going to do the summation of the values of these nodes for various paths, and we will find out which one has the largest path. So in this case, since we are doing the limitation of the greedy algorithm, so in this case greedy algorithm will not work. So let me tell you how. So let's suppose we are choosing a path that goes from 7 to 3 and then 99. So we know that we're going to get the highest value, which is 99 plus 3 plus 7. So which evaluates to be 99 plus 7 plus 3. So that is 109. So this is the largest sum. So in this path you can see that this is the largest sum. So ideally the solution of the problem should be this path 7 to 3 to 99. So ideally the solution should be 7 to 3 and to 99. But let's suppose a programmer says that no, I'm not going to use this path, or let's suppose he tries to solve this problem using a greedy algorithm. So what he's going to do is he's going to make an optimal choice. So he's going to make an optimal choice at each step. So let's suppose the programmer says that I want to use the greedy algorithm. So now he says that if we are on this node 7, and then what we are going to do is we are going to trace the next node which has the value of the node is higher than the previous one. Or you can say that because we want to make a decision here, so it says that what we are going to do is we are going to select the adjacent node which has more value than this one. So according to this is an optimal choice, and the optimal choice is to select highest value node, because if we will select the highest value node we will get the largest sum. Highest value node. So if we will select the highest value node, we will what the greedy algorithm will do is from 7 the path will go to 12, since 12 is greater than 3, and then it will go to 6. So you can see that it will go to 6. So the sum will give us the 7, 12 and 6. So these are the optimal choices that our greedy algorithm has made. So you can see that in this case using a greedy algorithm will give you a wrong answer, because we know that ideally the solution should be this one. So the largest sum is 109, but our greedy algorithm, since it is choosing the optimal choice at each step, then we are going to get the wrong largest sum. So why this problem has occurred? Even if we are solving the sub problems which have the optimal choices, they should contribute to make the problem optimized. But that's not the case, and the reason is that greedy algorithm is unaware of the future choices, choices. So you can see that in this example, the greedy algorithm was going like from 7 to 12 to 6, but it was unaware that in this path there is a node with a value 99, and which is going to make the largest sum much greater than what it is actually choosing. So that's the main reason greedy algorithm will select sum the wrong sum in this case. So that's the main limitation of the greedy algorithm, because it is choosing the optimal choice at a particular step. It is not considering all the data. So if it has considered the 99 as the data, so it would not have gone wrong. So that's the main limitation of a greedy algorithm. So a programmer should be careful in choosing a greedy algorithm, because if he would have chosen the greedy algorithm in this problem, he might have gone wrong. So I'm going to write here some of the properties, so that when these properties are true, you are going to select the greedy algorithm. So I'm going to write two properties here, and if a problem is following these two properties, then only you can use the greedy algorithm to solve that problem. So the first property is the greedy choice property. So if the given problem has the greedy choice property, that means a global optimal solution. That means our whole problem is optimal, and if we want to reach the optimal solution, the optimal choice at each step should contribute to the optimal solution. So it says the global optimal solution can be reached by choosing optimal choice at each step. So in this limitation part, you can see that it is clear that if you will choose an optimal choice at each step, you cannot reach a global optimal solution, which was to find the largest sum. So the next property is the optimal substructure property, which says that if a problem has optimal structure, so let's suppose the problem is the largest sum problem. So if it has an optimal substructure, that means it has an optimal sub problem. If an optimal solution to the entire problem contains optimal solutions to the sub problems. So you can see that in this example, if we are going to make an optimal choice, or these are the optimal problems or the optimal sub problems, then you see that it does not contain in our whole optimal solution, which is the path 9973. So our optimal solution does not contain the optimal sub problems. So this is the optimal substructure property. If any problem has these two properties, then you can use the greedy algorithm. And in the next tutorial, we are going to discuss the knapsack problem, which can be solved using the greedy algorithm. So thanks for watching.